This is the 2017 Edexcel paper 3, so all about different experiments. And we noticed this one before, that's an interesting thing, and we just thought, well, we'd give it a go. So essentially, this has 2 solenoids and some magnets on springs, and it states that, well, you're going to displace magnet A so that it oscillates, and the north pole's in and out, blah, blah. Simple harmonic motion, that gives you a clue, doesn't it? As this motion continues, magnet B starts to oscillate. The amplitude oscillation increases over time, so your first thing is, well, resonance. You're going to recognise resonance. So here it is, we set it up. So we've just got some magnets inside a coil of wire. I start this one oscillating, and you can see over there this one starts oscillating as well. So it's an example of resonance, but it's also a good demonstration of Faraday and Lenz's law. So when this one is moving up and down inside the coil of wire, you've got a changing flux linkage. So that's here, N, D, phi. So that's your ND phi in Faraday's law, and because you've got a change in flux linkage here, you have an alternating current over here. And well, currents have magnetic fields around them by the right hand grip rule, and that so currents have magnetic fields around them, so that causes a force on this magnet over here. So what we were expecting, yeah, I think you can just about see it, is for them to oscillate pi out of phase. So in other words, every half oscillation of this one is going the opposite direction. And that direction is opposite because of Lenz's law, which is just that minus in Faraday and Lenz's law. So when this one's going down, this one's going up. And when this one's going up, this one's going down. That's basically the explanation. Let's just have a quick look at what they said in the mark scheme. Yeah, we pretty much covered everything. As magnet A moves, its coil experiences a change of magnetic flux. This change in magnetic flux induces an EMF in the coil. The induced EMF causes a current in both coils. The current in the second coil causes a force to act on magnet B, driving magnet B into oscillation. Because both mass spring systems have the same frequency, resonance occurs. It really is almost like 2 separate 3-mark questions rather than one big 6-mark question. I always think one of the most important things, the most important skills for these longer written questions is being able to deconstruct the question and identify the different parts of it. So really, if this was just a question on Faraday's law and a question on resonance, you'd have found it really easy. You just recognise the area and just give the same explanation that you'd always give for Faraday's law and the same explanation you'd always give for resonance. So learn those set explanations and then just identify what set explanation needs to go into this context.